I am currently on page 3 of the packet, and we're still working on this idea of the value of each piece depending on what we establish as the whole. So number 1 is sort of the natural choice, right? Letting that yellow hexagon be the whole. I'm going to do number 3 with you. So looking at number 3, right, if I decide to let the whole be this shape here, which is composed of the yellow hexagon, right, so that's the yellow, and then it is made up of 2 parallelograms. Okay, so if I want to determine the value of the triangle, I have to determine how many triangles would make up the whole. Okay, so if I were to put the triangles on here, right, it would end up taking me, that would be 6, 7, 8, so 10 triangles would make up the whole. Okay, so that's how I would know that the triangle would then have a value of 1/10. Right, and then all the other pieces are relative to that, because I might try to say, well, how many trapezoids does it take to make up this piece, right? And if I tried to move my red trapezoids, you know, I'd have one here, and then this is more than one trapezoid, right? This would be the red trapezoid right here. And then, you know, I'd have 3 of them plus a little bit more. All right, so that doesn't work to do the same procedure that I just did, you know, where I found out how many triangles made up that shape, because there's not a perfect number of trapezoids that make up that shape. But then what I can do is I can consider the value of the trapezoid relative to the value of the triangle. Okay, so I could say, well, it takes 3 triangles to make up a trapezoid, right? So then that means that the trapezoid is 3 times the value of a triangle. If a triangle is 1/10, then there would be 3 of those tenths making that up, okay? And that's why I could put, remember when I just put the trapezoids on here and I had 1 piece left over, I had 3 of those 3/10. I had 9/10, and then I had a triangle that was missing, so I had 1 more 10th that I needed to complete the whole diagram, right, when I put the trapezoids there. All right, and then the parallelogram is made up of 2 triangles, so it's twice whatever the triangle is worth. Okay, so pause the video and try number 2. The answers will be provided, so I'm not going to go over every problem. I'm going to let you check your answers on the answer key, but try number 2 on your own. Okay, other exercises I want you to work on is number 4. In number 4, we look at, again, 1 occurs in different places, right? So this is relative. Each tick mark is relative, the value of each fraction shown is relative to where I put the 1. So notice in this case, in 4b, 1, 2, 3, 4, 5, right? That means that each of these spaces is 1/5. Okay, so if I want to find the value of this dot, well, I have 1 and 1/5, 1 and 2/5, so this would be 1 and 3/5. Okay, so again, we are relative to where we put the whole. Now, on the next page, page 4, first problem, says the rectangle represents 2/3. All right, so that means I have a drawing that is 2 of these things that I'm going to call thirds. So if I want to draw 1/3, right, do I want to break this up into 3 pieces? Right, so think about that. The rectangle represents 2/3, so do I break this up into 2 to 3 pieces? Right, and I hope you'd say no. I'd break it into 2 pieces, right? So if the drawing is the fraction, then I have to break it up into the numerator, number of pieces. When I do that, each piece, because this says the rectangle is 2 of these things that I call thirds, right? That means that this distance is this thing that I call a third. So if I want to make a whole, I have to add 1 more of those thirds. Okay, so go down to number 6. The rectangle represents 3/5. The rectangle is 3 of these things that I call fifths, right? I want to draw a fifth, and then I want to draw the whole. Okay, so pause the video and try that. All right, in number 6, I have 3 of these things that I call fifths. When the diagram shows the fraction, we divide up into the numerator number of pieces. All right, each one of these is a fifth. All right, then if I want to sketch the whole, right, how did I know to put 2 more pieces? It takes 5 of these things called fifths to make 1 whole, right? If I have 3 of them, right, then I would take the difference between 5 and 3. I would need 2 more. I'm not drawing a scale very well. Imagine that's exactly the same length as the rectangle before it. And that would represent 1 whole. So moving on to the next page, you are going to write rules. You're going to try some examples on your own, and then you're going to try to write rules. So if blank, so blank is the picture, or it could be an amount in a word problem. Eventually, we're going to take this same concept here, and we're going to extend it to some word problems. But if blank is the whole, how do you sketch A over B? And I'll give you a hint. You're going to say things like, I would divide the diagram into either A pieces or B pieces. Right? And then you'll describe how to sketch. Okay, so we just looked at, so let me point out that on the last page, we looked at this case. We were given the diagram was the proper fraction. There's a slightly different rule if you're given the diagram as an improper fraction. So as you're working on these, so I want you to try 1, 2, and 3. And I'm going to come down here though and change this mixed number. All of your mixed numbers, you are going to make improper fractions. Okay, so we're going to call this, right, 4 thirds rather than looking at it as 1 and 2/3. Okay, so we're going to focus on this as improper fractions. So see if you can generalize these rules. And I'll come back and talk about this a little bit more with you. Because again, in class, you'd be doing this in your groups and you'd have that opportunity to talk with your group mates about it. So I'll come back and go over some of this with you.